In this video, you will get to know about how can you solve any problem of dynamic programming. It's really easy if you know recursion. So without wasting any time, let's directly get into the video. So first of all, what is dynamic programming? Dynamic programming is basically a technique in which you memorize the solution for the problem which you have solved, which basically means you store the solution of a problem which you solved somewhere so that you can reuse it whenever you need the solution of that problem again. Let's understand this with a simple question. Okay, so we are on our screen right now, and the question which we are going to solve is really simple. We have to basically tell the nth number in a Fibonacci series. For those who don't know about Fibonacci series, it is basically a series in mathematics where the nth number is the sum of the previous two numbers. It is a series something like this: 0, 1, 1, then 2. Basically, we have two seed values, 0 and 1, and then further the numbers are sum of its previous two values. For example, here the number is the sum of 0 plus 1, then here 1 plus 1, then here we will get 3 because of 2 plus 1, and so on the series will go. So now let's think of its recursive solution. I'm intentionally solving it with recursion because I want to explain you dynamic programming. So as we know, we have two base cases. If n is equal to 0 or n is equal to 1, then we want to return that number. Otherwise, what we can do, we have to solve this by adding previous two numbers. So for example, we can do this: n minus 1 plus n minus 2, and then we can simply return. But now what's the problem with this solution? uh, its time complexity is exponential, which is really bad. How? Because let me show you its recursion tree. If we have n as 4, then the first call will go towards 3, as you can see here. First is solve n minus 1, 3, and then it will go towards 2 and then 1, then it will return 1, 0 will return 0, we will get 1 plus 0 here, and then this will return 1, this will return 1, we will get 1 plus 1, 2, and this again, this will return something, then this will return something, and finally we'll get the answer. But as you can see here in this approach, we are solving for the same value again. We have already calculated 2 here, but we are again calculating this 2. So how can we store the solution of this 2 so that we don't have to recalculate it here? We can simply create an array. Let me just quickly create it of size n plus 1. Why I have taken n plus 1, and I'll soon tell you. We can pass the array here. And then while returning, we can store the answer of that value in the array. That's why we were using n plus 1, because if we will just write n, the index will be 1 less than the original number, and we are accessing the n index. That's why I've taken the n plus 1. And if that number is already calculated, we don't want to call this recursive function again. So what can we do? If it has some value other than minus 1, then it means that we have already solved for that value. We can simply return it. So we can simply write here, if dpn not equal to minus 1, return dpn. And now as you can see, sorry, we have not passed dp here. And now as you can see, it ran in lot less time complexity compared to before. After this, you can optimize the solution further, but I'll talk about that in the later videos of the DP series which I'm going to start. So as you can see how we reduced exponential time complexity to just O of n with the help of DP. And as you saw that it was really easy to memorize the solution, the main part was to build the recursive solution. So there's a prerequisite before learning DP. You must be familiar with recursion. You must have a great command on it. After solving few questions, you will be able to notice few patterns. Like, for example, in some DP question, you have to explore all the possibilities for solving that question. So that was it for this video. I'm soon going to start a DP series where I'll be covering most important and most asked questions of DP, covering everything from intuition to brute force to most optimized approach. And this series is not going to be language specific. I will be using pseudocode to explain the approach so that you can code it in your language too. So if you found this video insightful, don't forget to like, subscribe and share it with your friends. Do comment down which type of videos do you want in the future. I'll see you guys in the next one.